Okay, our second law is the law of logarithms for division, and we'll work this the exact same way as we worked the first video. Is we will do the example first and then the proof. So what is the law actually? We'll start there. The law is that if you have a logarithm with a division statement as the input, you can break that into two logarithms that are being subtracted. Or vice versa, if you have two logarithms that are being subtracted with the same base, you can rewrite that as the quotient of the inputs of the two logarithms, x and y, with that same base a. Conditions, they're the same as the first law. X, y, and a all need to be greater than 0, and a cannot equal 1. So our example, we have log of 18 base 2 subtract the log of 9 base 2. We can't evaluate either of those without getting a decimal, but if we use the law of logarithms of division, we can put them together as a single log, and then we may be able to evaluate that one. So let's see here. Same base, so log with a base of 2. And since we're subtracting, the law of logarithms states that we should divide. So that would be 18 divided by 9. 18 divided by 9 is 2. So we have the log of 2 base 2. And using the definition of a logarithm, we can rewrite that as a power. So 2 to the exponent x equals the input 2. What's the exponent on 2? Well, it would be 1. And if we equate the exponents, we get x equals 1. So we are able to evaluate that if we put it together as a single logarithm. That's it for the example. If you'd like to stick around for the proof, here we go. To prove it, we're going to use a similar strategy that we used in the first video. I'm going to take my two logarithms on the left and write them as m and n. So our first log is log of x base a. I'm going to call that m. And our second is the log of y base a, and I'm going to call it n. If we rewrite these as powers, we would have a to the exponent m equals x, and we would have a to the exponent n equals y. In this example, we're not multiplying x and y, we're actually dividing them. So what is x divided by y? Well, that would be a to the exponent m divided by a to the exponent n. What happens when you divide powers with the same base? That's the quotient law of exponents. You subtract the exponents. So it would be a to the exponent m minus n. If we look at the right side, the left side of our law, we have the log of x divided by y base a. What's x divided by y? Well, we just wrote a statement. It's a to the exponent m minus n. So if we replace x divided by y with a to the exponent m minus n inside the logarithm, we have our logarithm. And this is the common property of logarithms, where we have a power inside a logarithm which share the same base. So we can rewrite this as just the exponent m minus n. What's m minus n? Well, m is, from our initial definition, the log of x base a, subtract n, which is the log of y base a. And there we have demonstrated the law. The law states that the log of x divided by y base a, log of x divided by y base a, is equal to the log of x base a minus the log of y base a. And that's what we ended up with, the log of x base a minus the log of y base a.